The main design challenge that I undertook in this project is integrating the rhythm action philosophy of Guitar Hero into our game. That includes integrating the Guitar Hero controller, specifically the Wii version of the controller, with Unity and getting it ready for our mechanics. The primary system needs to include a visual representation of the rhythm action mechanics, as seen in Guitar Hero, with the notes coming towards the player, controlled fret representation in game. These are the corresponding colors that are the same between the guitar and in screen. The notes that can be played are tap with strum, tap with no strum, and tap with strum and then hold. We also need to include the correct stems, going quiet when the player misses or mishits a note. Other feedback for mistiming and missing, a percentage of success rate at the end, and other methods to use the guitar to control the player movement in game. Earlier in the academic year, I worked on a rhythm action game as part of a game jam. This was the start of me working on a system that could inevitably be present in Strings of Mischief. The system here is more basic and less efficient, but it was a great early start to thinking about note chart layout and other gameplay issues that come up from the rhythm action gameplay. The things that I had to primarily worry about when in development of this game was when am I gonna be spawning the notes that I have to hit or the player has to hit, when are they being hit, and when are they going to be despawned because the player missed them or mistimed them, or whatever other feedback the game would have because of this. This is the main script that I made to keep track of the timing and the loop that the 20-second song of this game is. Even though this is very rough script, it was made possible to be standard, even though it's just a bunch of if statements, because I kept it in a very high priority when it comes to the script execution order, meaning that this would be always the first script that would have to be get resolved at any moment in the game. Another thing that I had to keep in mind is that there is a distance between where the note is initially hit or when it initially spawns in the game and the time it takes from it to get to from that position that has been spawned to all the way to the action area for the player. All notes, when they spawn, it takes them about 1 second to get from the original position to the place that they need to be hit. I did this because I felt that was the appropriate amount of time that it needs for the player to react to it, as it also is not moving too fast for the player to understand. And I thought the balance there was appropriate. All this information, when it came to the development of this game, is crucial to then be transferred to Strings of Mischief, as the logic would still be the same. Even though this is a 2D game, the whole logic of how the notes would physically move through the space would be the same. The game manager would also have to account for this, and the timings would be crucial to be done to the correct decimal place. The main challenge that I had to worry about this development cycle is how to get the Wii Guitar controller working with Unity. What I found is was the Unity Wiimote remote API. What this API does is it accesses all the data for of the Wii remote and it makes it all accessible in Unity. Now, this is a free to use package that I had to use and I will go on to showcase it next. To initially get connection with the Wii Remote and my computer using Bluetooth, I had to primarily use an emulator. This is because Wii Remote on its own was not made for a Windows purpose. So just to get the initial connection going on before I move on into how to connect it into Unity, I had to first make sure I have a stable connection with Bluetooth. Now, this wouldn't be an issue anymore after that, as the script itself does a lot to keep a stable connection. But for the initial testing of the API, this is what I had to do. We got the Wiimote API working sometime before the Christmas holidays, and this was crucial as we were able to do a small demo scene for our big presentation. To showcase how this works, you have to manually find the Wii remote. What this does is it looks at the Bluetooth connections of all the Wii remotes possible. This list over here gives you access to a bunch of uh, input feedbacks that the Wii remote would have, including extension controllers. This is the primary script that the Wiimote API comes with when you download the GitHub. This script gives you access to all the possible feedbacks and inputs that the Wii remote can give, while also allowing you to enable them. For example, we are using the extension controller of guitar, and it allows you to access all the buttons that the guitar has. Even though I have heavily modified the script and it's not the same as it is from the GitHub, it still gives you a very easy to use template for how to use this script. Like for example, to know when the button minus is pressed, you can attach that to a bool, because all that data is to see if when pressing is true and when not pressing is false. That way, this is something that can be very easily accessible from across all scripts. After knowing what the main systems that I have are, I had to get into this mindset of figuring out what I don't have. The way that I went on about this is I thought about refactoring and general whiteboarding. The script that you can see in front of you, it's a whiteboard script that I did as I was thinking about how I can change the long if statement script that I had from Bianca's game into something more self-sustainable for strings of Mischief. I did this also for a number of other scripts, supplementary systems, but also other things that might affect the main system, like how to spawn the nodes. Even though this was predetermined already by Bianca's game, I still had to do some figuring out, since now we're taking the game into 3D. Things like the camera and the environment could very well interact with it and probably interfere with it. And possible solutions could be to make it into a UI and rather not be physical. There was still a lot of thinking to do when it came to when the player is playing the song or when the player is not playing the song, and every other state in between, like when the player stopped playing the music and can go around and interact with the crowd, or even when the performance has entirely stopped. All of those minute systems would have to be tied back to the core systems of both the Wii controller and the timing of the songs. With continuous playtesting and note keeping, all of these details would eventually be ironed out, and we would come to what is the final prototype. In the final prototype, the main script handles the node chart layout and how the nodes come towards the player is far more refined. As you can see, rather than have hundreds of lines of a script with just a bunch of if statements, I only have one if statement with a loop with information that is handled by different types of lists. These are all lists of when the timing of the node is to make it spawnable, what type of node it is, since we have multiple nodes, as explained in the Guitar Hero section of the diary, and where it is that they're gonna be spawned. Again, going back to the same logic as what the Bianca's game was. So, on top of the Wiimote demo script that was given by the GitHub of the Wiimote API, here is where I make most of the inputs possible. There's many different states that the game has. For example, if you have a menu on or not, and any other state. The way that this is possible is I created a scriptable object variant, which I'm gonna be keep spawning and spawning and spawning again on each of the beats of the song that is playable in the game. The information that the scriptable object would have would then be accessible in those lists. Like for example, the type of note. 0 is the very first out of the 4 possible notes, which would be the tap with strum. The object that hits this is the location of the object that is traveling towards. This is good for me as I can change the lanes of the note that is coming towards. And of course is the timing, the exact second to milliseconds of when I need to be spawning this node that comes towards the player. I also have a spawn position modifier. Even though this script is far more refined, the overall system of the game struggles as it is too much information, and because in this game it's possible to replay a song again and again and again, even when putting the script at the highest priority in the script execution order, there's still some missed timings and latency issues. The spawn position modifier, which is found within the scriptable objects, tries to account for that. So the controls are usable in the game. As you can see, the player uses the toggle stick on the guitar to move, and the frets over here are appearable in the bottom right of the screen. This is the mode of the player before he starts getting into the performance. This is the stage where the player can roam around and sees all the possible areas that the player can rob and still in preparation for when the performance hits. When the player wants to perform, all they have to do is hold the 4 notes down and hit the strum, and the band spawns right next to them, and their notes start spawning. As you can see, the better the player plays, more people get distracted and put their hands up as an indicator for the people to get robbed. This is a whole different section, but the Wii guitar controller is integrated to this. What the player can do when it comes to this, they can move closer to the distracted people using the minus. As you can see, this is exactly what I just did, and we had 12 money more because of it. Another thing that I need to talk about is that the notes that come towards the player, the position that they're spawned on into relation of all the rest of the notes and the song itself, it's randomized. Not truly randomized in the script, but the positions that I've chosen to them, they're random. Further playtesting needs to be done, going note by note to see if it makes sense for the patterns that are created for the player to hit. To, of course, find the best patterns. So, as you've seen so far, the spheres are the type of notes that you tap and then hit the strum. The other notes are the small squares. The small squares, all the player requires to do is just tap with no strum, and then later on, the tap with strum and then hold the fret. So, as you can see, the sphere, which indicates that the player has to tap with strum, and then the cubes at the back that the player just needs to hold. The next aspect of design that I'm going to talk about is the key communications that I have with the music student that made the game for that made the song for our game. I gave them a document, of course, with before that having pitched them the game idea, and after they were on board, I sent them a quick and small document with all the key information that they will need to have, like what are the emotional goals of the game, what is the actual gameplay, and what are some touchstones that the music needs to hit when it comes for them to make the song. I gave them a list of inspiration and examples, and I made it clear for them that this is strictly a direction or an inspiration. They're more than welcome to use whatever template or whatever artistic choice they want on the song. We had a lot of going back and forth with them sending me the songs and the progress of them and letting me know how it's going. I was very happy with it across the whole process of it, and the song came out great. The last thing I want to talk about in this dev diary is what was the project and file management that we did as a team. Primarily, the way we worked was using a Trello, of course, when it came to breaking down tasks and what it is that needs to be done within those tasks, and of course, subtasks. But the main way that we enforced this is through the way that we used our GitHub. We created many branches that we would then, each of us would work on their own branch, and then we would merge the branches together just so that everyone was working on time. We overall had 45 commits, with of course more coming as we're still working on the game, and we will be working on the game even after our initial deadline for this module. Initially, the project was committed back in February. Of course, as you've seen in the dev diary, I was working on this idea of the game way before this, but this is when we as a team came together and started working on the many different aspects of the game. We made regular commits with thorough explanations of what each person was working on, and of course, we would create different branches for each person to be able to work on their own stuff and then come back together and merge those different branches into the main branch and test out everything together.